Hello, everybody. I'm going to describe the results of a project that has generated a high spatial resolution map of land cover and flood hazards in the coastal and wetland areas of the southern U.S. from Florida to Texas along the coast of the Gulf of Mexico. This area is prone to flooding both from the land and from the ocean. It's an area that has a population of now over 60 million people. In 2020 alone, it was affected by 8 major storms that made landfall. And so it is a critical area where we can understand the risks that people are exposed to. The project has these research questions. Basically, we're looking to understand the extent and distribution of wetlands and developed areas along the coast of the Gulf, how these are related to topographic variability, what are the zones that are prone to flooding, and how do hurricanes affect land cover and the recovery of wetlands in this region. And we're using new technologies from both space, airborne, and computational. The approach is multidisciplinary. We're using satellite data from Maxar, specifically WorldView 2 and 3 satellite data. We collected over 13,000 images and mapped land cover at about 2-meter resolution. We also collected LiDAR data from aircraft that has been processed by the Hart Research Institute in Corpus Christi. These maps are also at 2-meter resolution, and they were put together from over 170 surveys. The University of South Florida is also flying drones in the region and mapping very high spatial resolution topography and land cover using a technology called surface from motion. The data products are served through Google Earth Engine. We have a collaboration where we have developed an application that allows you to visualize and download these data. The application in Google Earth Engine is found at this web link. This web link offers the processed 13,000 images for the Gulf of Mexico region along the southern US for the period 2009 to 2018. I'm going to show you an example of how this works. Basically, you have a split screen where you can define a period to be displayed on the right-hand side of the screen and another on the left-hand side of the screen. And you can compare different types of vegetation cover through this slide bar. Here in this example, you're comparing 2009 to 2013 to 2014 to 2018 for all the land classes that we developed. In an example, you can then download the data and make an assessment of what was lost and what was gained. For example, here you can see that there was a major loss over these period from prior to 2013 to post 2014 of grasslands by the Hart Research Institute. Is compiled from over 170 surveys and that were all put together in a standardized fashion. And you get products like this. On the left-hand side, you have the surveys that were used to produce the DEM for Texas. And on the right-hand side, you have the Bare Earth product. This is also served now through Google Earth Engine. This is an example of a higher detail in Texas for the Matagorda area. On the left-hand side, you have the Bare Earth product. And on the right-hand side, you have all the points topography. The surface from motion product derived from the USF drones has a spatial resolution of about 4 centimeters, and it covers small areas. Here's an example for Fort DeSoto in the Tampa Bay estuary, where we flew the device and then compared the product to the LiDAR topography. Clearly, the LiDAR topography product is much coarser in spatial resolution, and it was also collected over different time frames, so there's going to be differences. But you can see that there's a product and can be applied at very high spatial resolution. This product on the right-hand side is also multispectral. The project now offers these products through Google Earth Engine for anybody to use. This can be used, for example, for biomass estimates or to understand what areas may be prone to flood and what type of land cover would be affected. So this is one of the things that we plan to do, is understand better the distribution of wetlands with specific within specific topography ranges. We are going to compare the DEM to other types of height observations and use the UAV drone data to compare small regions between years. We're looking for collaborations, so anybody that's interested in working with us on these data is either able to use it or work with us. We want to use this for large-scale biodiversity assessments, and we offer experience in processing large data for these types of studies. So thank you very much. Please don't hesitate to contact us at carib@usf.edu. My name is Frank Muller Karger. Thank you. Bye-bye.